Hey guys, Mr. Burns here with your video for lesson 10.1, Introduction to Statistics. On average, how many people visit Disneyland each month? How many people are in a typical class at your school? What is your favorite ice cream? What is the favorite ice cream of students in your class? These are example of statistical questions. A statistical question is a question that can be answered by collecting data. One single answer is not expected from a statistical question. A good statistical question is one in which the data will vary. So here are some examples of statistical questions. So one example of a statistical question is how old are the students at your school? Why is that a statistical question? Because the data, the information varies. Another example is what are grade point averages of seniors in high school? Again, the data will vary. That's why this is a statistical question. Last question is how many hours of homework did students in your grade level do last night? Okay, so again, that's a statistical question because the information that you gather will vary because not everybody's going to study the same amount of time. Examples of non-statistical questions. So one example, okay, over here would be example of how old is the oldest student at your school? That's not a statistical question because it's too specific. Another one is what is the highest grade point average a student can earn in high school? Again, that's too specific. All right, it's too specific a question, and there's not enough variation. And last but definitely not least, how many hours of homework did you do last night? Again, too specific. It's only focusing on one person, so there's no variation in the data or the information being collected. Moving on. Statistics is the process of collecting, displaying, and analyzing a set of data. Consumers may use the data to decide which products to buy. Businesses use data to make important financial decisions. Data can be either categorical or numerical. Categorical data is data collected in the form of words. For example, if you collected data on your friend's favorite food, they would respond with specific words like pizza, tacos, hamburgers, etc. Numerical data is data that is collected in the form of numbers. For example, if you ask your friends how many apps they have on their phone, they would respond with a number such as 5 or 32. If you have 32 apps on your phone, you know what? I better be quiet. Anyways, moving on. Example number 1. It says Mrs. Crenshaw asked her 6th grade students the following question. First question is what is the age in years of students in 6th grade? Second question, what is the age in months of students in 6th grade? It says which question will give data that is more varied, and explain your reasoning. Will it be the first or for the second? The solution, what they say the answer is the second question will give more varied answers. Since Mrs. Crenshaw's students may be close to the same age in years, there may be a little difference in students' answers, okay, 11 or 12. Because there are 12 months in a year, asking students' ages in months could give more varied answers. For example, 11 years and 3 months is equal to 135 months. 11 years and 4 months is 136 months, and so on. So there's more variation in the information, okay, when you ask for months instead of years in this type of a situation. Okay, let's move to the next page. In example number 2, it says which is a better statistical question for a gym owner, okay, to ask about exercise, and explain your reasoning. First question is did gym members come to the gym at least once per week? 2, what is the average number of days per week people at the gym exercise? Okay, so the solution, okay, again, the question asks us which is a better statistical question, the first one or the second one. The solution, they say, okay, is the second question is better because it will give the gym owners more specific information. The first question will only give you an answer of yes or no. This question does not give any information about how many times a member comes each week. When you are collecting data, it is important to be aware of bias and how the data was collected. Bias is a systematic error that contributes to the inaccuracy of your data. Here's an example, 4 examples of what bias and how it affects mathematics. okay, in statistics. So example number 3, it says explain how there could be bias in each of the following situations. A restaurant owner asks customers to rate their dining experience on a scale of 1 to 10 as they leave the restaurant. So that might cause a bias. B, a worker surveys people outside the monkey exhibit at the zoo asking, what is your favorite animal at the zoo? That might show some bias. Third question, C, an ice cream company surveys customers asking, what is your favorite type of ice cream? Vanilla, chocolate vanilla, or caramel fudge swirl? And D, a hotel leaves a comment card in each room where customers can choose to rate their experience at a hotel on a scale of 1 to 0. So each one of these scenarios introduces some form of bias, okay, or systematic error in their questioning. Part A says, the answer to A says customers may not feel comfortable being honest with the restaurant owner. So you as the owner, if you go up there and ask them, hey, rate my restaurant from a scale from 1 to 10, if you go up there and ask them, you specifically, they may give you a higher rating, right? Because they don't want to insult you as the owner. B, people outside the monkey exhibit may be more likely than other zoo visitors to enjoy monkeys. Their opinions may not represent all the visitors at the zoo. So if you ask people there that are at the monkey exhibit, what's your favorite animal? Well, they might be there because monkeys are the favorite animal. If you want to make this more accurate, you would ask more people. C, the solution is only giving customers 3 options to choose from may not give the most reliable results. Many customers would likely have a favorite that was not one of those 3 flavors. So again, that's a systematic error that contributes to inaccuracy in the data, because they may like something that's not on that list if you're only giving them 3. Okay, it's too constraining. It's too specific. D, optional surveys optional surveys often receive responses that are really positive or really negative, and not many in the middle. So again, this is a bias, so you're going to get extreme answers. You're not going to get more even-handed or moderate answers. You're either going to get people that really like it or really don't like it, and those are the people that usually fill out surveys. So that's just an example of bias in mathematics. Okay, moving on. Another way data can be misleading is in how it is displayed. Changing the scale of axes can create very different impressions of a data set. So here we go. Example number 4. Students at Humphrey Middle School collected data on the type of music students would prefer for the next school dance. The bar graph shows the results. So along the x-axis, so let me see, make sure I got a picture. So along the x-axis, that is your category of music, right? And then along the y-axis here, okay, that's your percent, represents the percent of students. So rock and roll, 28%, okay, prefer rock and roll. Looks like about 23% might prefer rap. 24% is country, and then let's say 25 would prefer R&B. So it says A, what is misleading about this graph? B, draw a new bar graph that is not misleading. C, why might someone use the original graph to represent the data? So this is the original graph. Okay, and then we're going to show you what the other graph might look like. So the reason this is misleading is it doesn't start at 0. This makes it appear that rock music had a large majority of votes. Okay, so if you look at the original graph there, the original display, it looks like rock and roll. More kids wanted to listen to rock and roll than anything else. So anyway, so it's misleading in that regard. There is really only a 5% difference between rock and roll and rap, and you'll see that here in the next graph. B, drawing a new graph. So here's your new graph. Okay, so this is your new graph, starting at 0, which you should, and then it's going up by even intervals. So 0, 4, 8, 12, 16, 20, 24, 28. So it's going up by intervals of 4. So again, this is along your y-axis, and then the rock and roll, the category, that's along the x-axis there. So this new bar graph actually represents the distribution of the information a lot better. Okay, it gives an honest representation of the information. So the genres of music are actually a lot closer than originally shown in the other graph there. All right, which brings me to part C. Part C says it asks why might someone use the original graph to represent the data? Well, someone who likes rock music might use the original graph to make it appear that rock music was preferred by far more students than the other types of music. This is like at a dance. Rock and roll depends, right? If it's rock and roll music that you can dance to, kids might like it. If it's really heavy metal type music, yeah, not so much, you know. So, anyways, yeah, so it's really important to display your information as accurately as possible so that people can make really good objective decisions based on the numbers. Okay, let's take a look at the next page. Okay, here we are in lesson 10.1T, Introduction to Statistics. So we're on the tiered worksheet. So for numbers 1 through 4, it says classify each set as categorical or numerical. So categorical data is words, okay, words or phrases, and numerical, it's just that, it's numbers. So on number 1, the brand of shoes that students in your class are wearing. Is that categorical information or numerical information you're looking for? That would be an example of categorical information that you're looking for. Number 2 says the number of books that each student in your school has. In case you're looking for a number, that would be numerical. Oh, and let me back up on number 1. The brand, so you're looking for the brand of shoes. That's categorical. Okay, 3. The prices of 20 random cars at a used car lot. So what are you looking for? The prices, okay, of 20 random cars. So that would be, again, numerical. Number 4, students' favorite restaurants. So if you're looking for their favorite restaurants, you're looking for categorical information. All right? Okay. So for numbers 5 through 7, it says for each exercise below, circle the question that is a statistical question and then explain your reasoning. So number 5, we've got how many times did students at your school go to the mall this month? Or how many times did Stacy go to the mall this month or last month? So what is a better statistical question? So the better statistical question would be A. And why is that? Is because the other question leads to a specific response. So question B, or answer, question B, okay, leads to a specific response. It's only measuring one person. Okay. Here we go with number 6. On number 6, it says, what was students' favorite music in 2018? Or B, which movie earned the most money in 2018? So in this case, okay, what's a better statistical question? You're looking for a broad range of information, a broad range of responses, okay, nothing too specific. So that would be A. All right, and the reason for that is the second question has only one answer. So the second question has only one answer. That's it. Okay, number 7. On number 7, it says, circle the statistical question that will give more varied responses and explain your answer. Is it A, how many songs do students download per month? Or the second question, how many songs do students download per year? So which one of those is going to be give more varied responses? It would probably be the second one. Okay, and the reason why is the longer time frame, okay, will provide more answers. So the longer time frame provides more answers. All right, on to the next page. Okay, down here on the bottom of this page is actually the instructions for the second page. So everybody look down here. Okay, so these are the instructions for the next page. It says describe the possible bias in each survey question. How could you change each situation to eliminate the bias? Okay, so again, describe the possible bias or systematic error, okay, in this information. All right, and then how could you change to eliminate the bias? All right, here we go. Now on to the next page. So on number 8, it says you email random people asking, what was the last movie you saw in theaters? So what type of bias is this? So that's what this represents up here. So this is like your bias. So like a who bias, a what bias, when, where, how bias. So who do you ask? Is it too specific? What do you ask? Is the answer, is it a leading question, right? When did you ask him? What time of the day? What part of the year? Where? What location? Okay, did you ask the question? How? How did you convey the question? How did you ask them the question? So in this case, okay, this would be an example of how. Okay, because you're emailing random people. So this is an example of how you ask the question. Okay, so write that down. So how you asked the question. Okay, what would you change? So in this case, on number 8, don't use, so use other methods other than email to ask the question. Okay, so you want to use other methods other than email. Okay, so you use other methods, comma, other than email, okay, to ask the question. Because not everybody has email. Okay, some people don't have access to the internet. Some people don't have a computer. Okay, so anyways, yeah, use other methods, okay, other than emails to ask questions. Okay, on number 9, it says you ask 50 students in the locker room after school if they participate in after school sports. So here we go. You ask 50 students in the locker room after school if they participate in after school sports. So you have to ask yourself, what type of bias might this be? A who, what, when, where, how bias. I would call this a when bias. Okay, when. So when you ask the question. All right. And what changes would I make if it were me? I would ask the kids, at different parts of the day, So if I were to make changes, I would ask students at random times, throughout the day. All right. And that helps to eliminate some of that bias there. Okay. On to number 10. So on number 10, it says a graph in the local newspaper showed the change in the percent of money being spent on education in the last several years. So it says education funding drops. Oh my gosh. Along the x-axis there, they show you the years, that's the time. And then along the y-axis, they show you the percentage of spending. So for part A, what is misleading about this graph? For me, the one thing that sticks out, okay, for this is the graph doesn't start at 0. So the scale does not start at 0. And then B, it says, why might someone use this graph to display information? They might use it for a lot of reasons, but if you look at the bars from 2004 all the way to 2007, it looks like the spending, educational funding is pretty good. And then all of a sudden, you see this huge precipitous drop, okay, from 2007 to 2008. Sorry about the bird in the background. So, okay, one reason why someone might use this data is to exaggerate the drop in funding. So they might use this graph to show a large drop in school funding. All right. Hopefully that helps. A lot of writing with this lesson. That's how statistics is. Okay, a lot of writing, a lot of research. So if you guys have any questions, make sure you ask someone. And if you need to ask me for help, make sure you guys ask me for help. I'll be more than happy to confuse you. That's all I got. Mr. Burns, out.